So in the next part of this video, we will discuss exponential function application. So basically, we will encounter exponential growth and exponential decay as the main application of exponential function. So first one, we have exponential growth. So if a certain quantity increases by a fixed percent each year, or any other time period, the amount y of that quantity after t, which is the time, can be modeled by the function y equals a quantity 1 plus r raised to t. Okay, where a is the initial amount, r is the percent expressed as a decimal or the rate, 1 as a constant value, t is the time, and 1 plus r is called the growth factor, and y is the final amount. Okay, so for example, we have the problem, Carlo deposits 100,000 in a savings account. The account pay 4% annual interest. So if he makes no more deposits and no withdrawals, calculate his new balance after 15 years. Okay, so we have first the initial amount, a equals 100,000, the rate 4%, then change 4% into decimal, so we have 0.04, the time period 15 years, and we are asked to find the total value or dy. Okay, so we have the formula for the exponential growth, y equals a times 1 plus r raised to t. Then input the following information to the formula. So we have y equals 100,000 times 1 plus 0.04 raised to 15. And after simplifying, we will have an answer of 180,094.3506. Okay, so therefore, Carlo's new balance after 15 years is 180,094.35. Okay, so round up the answer to the nearest hundreds. Okay, so the answer is 180,094.35. So next problem, we have a bacterium grows at a rate of 25% each day. There are 500 bacteria today. How many there will be? A, tomorrow, B, 1 week from now, and C, 1 month from now. Okay, so we have again the formula, y equals a times 1 plus r raised to t. So the initial amount of the bacteria is 500. Okay, so first, we need to calculate for the total value of bacteria after 1 day, since it is in the problem that we need to find the number of bacteria tomorrow. So basically, it is 1 day. Okay, so for tomorrow, we have y equals 500, so the initial amount, times 1 plus the rate, 25%. So change it into the decimal, 0.25. So 1 plus 0.25 raised to 1. Okay, then simplify. So 500 times 1.25, so we have y equals 625. So therefore, there are 625 bacteria tomorrow. So we already answered the first one. So next is 1 week from now. So for 1 week from now, so we have the same initial amount, 500, and the same rate, 0.25, but the time period will become 7 since there is 7 days in a week. Okay, then simplify. So we have 500 times 1.25 raised to 7. So y equals 2,384.19. So round up, we have 2,384. So therefore, there are 2,384 bacteria 1 week from now. Okay, so this is 1 week from now. So next one, the third is 1 month from now. Okay, so again, we have the same initial amount and the same rate, but the time period again changes from 7, so from a week to 30, since 30 is for 1 month. Okay, so in exponential growth and decay, 1 month is always 30 days. Okay, so simplify. Y equals 500 times 1.25 raised to 30. So y equals 403,896.76. Then round up, so we have 403,897. So therefore, there are 403 bacteria 1 month from now. Okay? So that is all the problems or sample problems in exponential growth. Okay, so next one, we have the exponential decay. So unlike in the exponential growth that the value increases as the time passes, in exponential decay, the value decreases by the given rate at a certain time. Okay, so if a certain quantity decreases by a fixed percent each year or any other time period, the amount y of that quantity after t, which is the time, can be modeled by the function y equals a times 1 minus r raised to t. So again, where a is the initial amount, r is the percent decrease expressed as a decimal, t is the time period, 1 minus r is called the decay factor, and y is the final amount. Okay? So example number 1. The value of a new car in 2011 was 500,000 pesos. It depreciates 5% each year. How much will the car be worth in 2024? So depreciates means decrease of value. Okay, so we have the initial amount, 500,000. Next, we have 5%, or 0.05. And the time is 13 years since from 2011 and 2024, it is exactly 13 years. Okay? So 2024 minus 2011 is 13. Okay? So 13 years. And we're asked to find the y value or the total amount after the value depreciates in 13 years. Okay? So the formula is y equals a times 1 minus r raised to t. And insert all the information we have. So y equals 500,000 times 1 minus 0.05 raised to 13. So the answer after simplifying, we have y equals 256,671.0416. Okay, so therefore, the car worth 256,271.0416 in 2024. Okay, so that's how we solve exponential decay. Okay, so another example, a certain radioactive substance decays half of itself every day. Initially, there are 10 grams. How much substance will it be after 8 days? Okay, so again, we have this formula for the exponential decay. So y equals a times 1 minus r raised to t. Next, we have the initial amount of 10. Rate of decays half. So since half, it is 1 half. So 0.5 in decimal form. Okay? And raised to 8. So 10 times 1 minus 0.5 raised to 8. Okay? Then simplify. We have y equals 0.04. Okay? So therefore, after 8 days, only about 0.04 grams of the substance will remain. Okay? And last one, we have, suppose that the half-life of a certain radioactive substance in 5 days and there are 10 grams initially, determine the amount of the substance remaining after 20 days. Okay? So, meaning, every 5 days, this certain amount of a radioactive substance is half. Okay? So, it decreases by 1 half of itself. Okay? So, we use the fact that the mass is half every 5 days. So, from the definition of half-life, thus we have initially, so at time equals 0, so 0 days, the amount of substance is 10 grams or the initial amount. Okay? So after 5 days, the amount will be reduced to 1 half, so we have 5 grams. After 10 days, it is also again reduced by a half, so 2.5 grams. After 15 days, so it is 1.25 grams. And after 20 days, the amount of the substance remain is 0.0625 grams. Okay? So this is the answer, 0.625 grams. So in using the formula, so we have A is equal to 10 grams. R is 50%. Okay, so 0.50. Then the time is 20 days over 5 days. Since the total days, the half-life cycle is 20 days and every 5 days, it reduces to half. Okay, so we have 20 days over 5 days is equal to 4 days. Okay? So, y is equal to unknown. So, y is equal to a times 1 minus r raised to t. So, substitute the given information to the formula. So, we have y equals 10 times 1.0.50 raised to 4. Y equals 0.625. So, therefore, the remaining amount of radioactive substance after 20 days is 0.625 grams.